Okay, we've got this quotient of functions. I'm going to do this one two different ways. I'm going to do it with quotient rule, and then I'm going to show you what I think is kind of a shortcut to do this using chain rule instead. And you'll see chain rule and product rule. It's really a combination. I think it's easier the second way, but either way would be fine. So here's using quotient. Okay, so y prime will be the derivative of the top. The derivative of 8x plus 5. Derivative of 8x is just 8. The derivative of 5 is 0, say. 8 plus 0 is just 8. Times, leave the top alone. Or, sorry, leave the bottom. Minus the derivative of the bottom. The derivative of 12x is just 12. Minus derivative of 4 is just 0. Times, leave the top alone. All over the bottom squared. So derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. I almost forgot the squared there. Now we could clean this up. Like we could do some distributing here. Let's see. I think that's 96x minus 32. And then I'm going to have to distribute here minus 96x minus 60 all over 12x minus 4 squared. Those just happen to cancel. And I think we get negative 92 over 12x minus 4 squared. That's using quotient rule. Now let's do it using chain rule. Really, it's chain and product rules. So I'm going to rewrite my function as y equals 8x plus 5 times 12x minus 4 to the negative 1 power. I'm going to bring that guy up here and make him a negative exponent. And then I can use product rule. So now y prime will be the derivative of the first times the second. Leave it alone. Plus now, because we're doing product rule, the derivative of the second. Oh, now I got to use chain rule here. The derivative of this guy will be negative 1 times, leave the inside alone, to the negative 2 times the derivative of the inside. So that's just chain rule on this guy, and I still got to multiply that by leaves the top alone. So derivative of the top, leave the bottom alone, plus derivative, I keep saying top and bottom, I'm sorry. Derivative of the first times the second, plus derivative of the second times the first. Now, look at that. This does not look as pretty as that did. Oh, this is kind of nasty. This is 8 over 12x minus 4 minus 12 times 8x plus 5 over 12x minus 4 squared. Oh, if I were going to combine this together, I would have to multiply top and bottom of this guy by 12x minus 4. And then I could combine like terms. And like you should be able to see now that That's exactly what we had here. So is it really better to do it this way? Maybe not in this problem. Maybe so. It depends on how clean you want it. But what if I wanted the derivative of this guy? So I could do this using chain rule. Oh, let me make that a little more interesting. I could do this guy using chain rule or quotient rule. Let's do chain rule first this time. So I would want to think of this as x minus 3 to the negative fifth power. Then, using chain rule, the derivative would be bring the negative 5 down front, leave the inside alone. That now drops down by 1. Negative 5 minus 1 would be negative 6. Times the derivative of the inside. The derivative of x minus 3 is just 1. I just get negative 5 over x minus 3 to the sixth. I'm done. That's the derivative. If I use quotient rule, now I have to do the derivative of the top, 0. Derivative of a constant is 0. Times, leave the bottom alone, minus derivative of the bottom. So now I got to use chain rule no matter what. The derivative of 5x minus 3 to the fifth would be 5x minus 3 to the fourth times the derivative of the inside, which is just 1, all over the bottom squared. Okay, let's clean that up. 0 times anything is 0, so all of that disappears. I get negative 5 x minus 3 to the fourth over x minus 3. Rules of exponents. A power raised to a power, you multiply. Next, rules of exponents. When you're dividing, you could subtract. Or you could think of this like I've got 4 on top and 10 on the bottom. I'm going to cancel out all 4 of those, leaving 6 on the bottom. Hey, that's the same thing I got here. Okay, so the point of this video is sometimes when you're looking at a quotient rule problem, it might be easier to bring that bottom up to the top with a negative exponent and use chain rule instead. It might not. On this other problem, they were both kind of nasty either way, but it can be done. If it's something like this, it's always easier to use chain rule. If you've just got something over something to a power, if there's a constant on top, definitely if you got a constant on top, bring this guy up with a negative exponent. Chain rule is so much quicker.